All right, so in this lesson, we're going to multiply and divide rational expressions. All right, so last section, we just simplified rational expressions. And you're going to see multiplying and dividing is very, very similar to just the simplifying part of it. All right, so all we have to do is factor each part of your fraction. All right, so factor the top, factor the bottom. And when you're multiplying, so if you see a multiplication symbol between your two fractions, you can cancel out whatever's the same on the top and on the bottom, right? Or you can cross cancel. All right, and then dividing, you would keep, change, flip, and then after keep, change, flip, you would do the exact same thing as multiplying. So then after you do this part of it, then cancel, you would go back to the rules for multiplying, right? They work exactly the same after you divide. There's one little thing that you do in the beginning, but otherwise it's exactly the same. All right, so let's do some examples. Something like this one, number 1. All right, so I have a fraction multiplied by another fraction. All right, now with multiplying, you're allowed to multiply straight across. All right, so I can do top times the top, bottom times the bottom. Before you do that, you do want to make sure that everything is fully factored and simplified. All right, so if you look at each part of your fractions, there's only one part that we can do stuff to, and it's this x squared minus 9. All right, and that x squared minus 9 can factor as an x plus 3 and an x minus 3. All right, that is a difference of squares. All right, and now looking at what's the same on the top and on the bottom, within our fractions, there's nothing that's the same, but there's something here that's the same with something over here. All right, so you're allowed to cross cancel. All right, so if we cross cancel, the x plus 3's go away, and the only thing that we're left with on top is the original x minus 2, and then the x minus 3 that we got from factoring the difference of squares. And then the only thing left on the bottom after canceling is x plus 4. All right, and there's nothing more we can do to this, nothing more we can factor, so I can leave it. All right. You can choose to FOIL it if you want to. I wouldn't. I would just leave it like this. I'm telling you guys that it's okay to leave the top and the bottom factored. Right? You don't have to FOIL it. That's going to create a little bit more work for you. Right? So you can do the exact same thing with the next one. All right, we're going to look at each part of this fraction, and we're going to factor what can be factored. It looks like we have something very similar. Right? We have an x squared minus 9 that we can turn into an x plus 3 and an x minus 3. All right, and now looking at what's the same on the top and on the bottom, in the exact same fraction, the x plus 3 and the x plus 3 can cancel out. But we can also cross cancel. I have an x minus 3 and an x minus 3 that's the same. So with multiplying, it's just whatever's the same on the top and on the bottom. And it looks like the only thing that you're left with is an x plus 4. So that would be your answer to this problem. All right, so hopefully not too bad, similar to what we did in the previous lesson. All right. Now they get a little bit bigger, right? I know it kind of seems like quite the jump to go from one like that to one like this, but it's still the same idea. It's just factoring. So what I like to do is I like to factor each and every single part of our fraction, right? So I'm going to factor the top left, right? And factoring the top left, it's going to be 2 times negative 6. I'm looking for factors of negative 12 that add to positive 1. Right, and that's going to be a positive 4 and a negative 3. So this is going to be x plus 4, x minus 3, and then it can divide by 2, slide and divide. All right, and then doing that, I'm going to rewrite the entire thing below it. 4 over 2 simplifies, that's going to become an x plus 2. 3 over 2 does not simplify, so this is going to become a 2x minus 3, right? Just factor the top. We can do the exact same thing with the bottom. So I'm going to factor x squared plus 4x minus 5. You're just looking for factors of negative 5 that add to 4. And that's going to be an x plus 5 and an x minus 1. All right, so that's our first fraction. And it looks like in our second fraction, right, we can factor the top and the bottom again. So I'm going to factor the top. That's going to be a GCF of x. And you're left with an x squared minus 3x plus 2, and then you can factor the inside even more, right? That's just a trinomial. We're looking for factors of positive 2 that add to negative 3, and that's going to get me x minus 1, x minus 2. All right, so that's this part of it fully factored. All right, and now let's do the last little bit, this little bit. It looks like the only thing we can really do here is take out a GCF. We can take out a GCF of 2x, and we're left with 2x minus 3. All right, so the hardest part of it was just factoring each part of it and staying organized, right? If you stay organized, that's going to get you pretty far in these kinds of problems, because the work itself you're seeing isn't super difficult. It's just you might get lost at some point. All right, so just be careful with that. And now what you want to do is cross out anything that's the same on the top and on the bottom. So x minus 1 is the same, 2x minus 3 is the same, and even these x's are the same, right? These x's are identical, so I can cross them out. And they are factors, right? So that's one thing that I want to make clear. They are factors. I don't see a plus in front of that x or between the 2 and the x, so I'm allowed to cross these out. If there were a plus in between it, you could not cross them out. Again, I'm going to say it a lot. You can only cancel out factors, not terms. All right, so then what I'm left with on the top is an x plus 2 and an x minus 2. All right, x plus 2, x minus 2. And then on the bottom, I have a 2 and an x plus 5. Nothing more we can do to that. I would leave that alone. All right, I know it's tempting. You see the 2's, you want to maybe try to cross them out. You see the x's that are the same on the top and the bottom, you want to try to cross them out. Do not do that, because none of these are matching factors, right? Only matching terms. All right, and something like this one's already factored for you. All right, so here you're just looking at what's the same on the top and on the bottom. X minus 1 is the same. I can cross those out. These are matching factors. And then 5 and 25 I can cancel out. That's going to get you 1 over 5. So the only thing that you're left with on the top is a 1. And on the bottom, you're left with a 5 and an x minus 2. All right, that's all we got to do there. Nothing more we can do. You can distribute that 5, but I would leave it alone. This is an acceptable answer to me. All right, so another multiplying one. Just like the others, you just want to make sure that everything's fully factored. So I'm going to factor the top left, x squared minus x minus 6. I'm looking for factors of negative 6 that add to negative 1. And that's going to get me a negative 3 and a positive 2. All right. The bottom left is a perfect square trinomial. If you didn't recognize that it was a perfect square trinomial, you'd have thought what multiplies to 9 and adds to 6. And that's going to get you 3 and 3. So I'm actually going to write it like that. Maybe that's how some of you would have written it. So x plus 3, x plus 3. All right. And then x plus 3 on top does not factor. That's fine by itself. X squared minus 4 on the bottom is a difference of squares. So it's going to be x plus 2, x minus 2. All right. And then we're just looking for what's exactly the same on the top and on the bottom. It looks like we have an x plus 3. That's the same. And we also have an x plus 2. And it looks like that's the only thing that's the same, right? So we get x minus 3 left over on top. And on the bottom, I have an x plus 3 and an x minus 2. All right, you can leave it like that. Don't FOIL the bottom. I mean, if you can, it's not wrong, but I mean, it's just extra work. All right. So then we move on to something like this. The only way that this is different is that now there's a division sign in between. All right, so with division, when you're dividing, I like to keep, change, flip, right? So you maybe remember dividing fractions like this, maybe like in middle school or whenever you learn this, but keep, change, flip. You would keep the first. So I like to rewrite it completely first before I do anything else. I like to turn it into a multiplication problem. So I get x to the third minus 8 over x squared minus 4. Change the division to multiplication and flip the last fraction. So this becomes x to the third plus 8 over x squared plus 2x plus 4. All right. And so now let's try to factor every part of it, right? Now this looks like one that we've done so far, right? We've been doing a lot of multiplication ones. All right. It looks like the top, this can factor as a difference of cubes. So that's going to be x minus 2, right? This is the pattern, the same, opposite, always plus. So this is going to be an x minus 2, x squared plus 2x plus 4 on the top. And it looks like the bottom is the difference of perfect squares, right? X squared minus 4 is going to get you an x plus 2, x minus 2. All right? And then it looks like our top in the other fraction is another cubes, right? This one's the sum of cubes. It's going to be an x plus 2. And you would do your same opposite always plus. So it's going to be x plus 2, x squared minus 2x plus 4, right? Square the first, square the last, product of the two in the middle. All right, and then this on the bottom, you can try to factor it. It cannot factor. There are no factors of 4 that add to 2, so it's going to be x squared plus 2x plus 4, all right? And then now you're just looking for what matches on the top and on the bottom. It looks like I have a matching x minus 2 and x plus 2, and then I have this entire trinomial on the top and on the bottom that match. All right, so the only thing that doesn't cancel out is x squared minus 2x plus 4. That's the only thing that didn't cancel, so I would leave that alone, just like that. All right, last page of these 3 division problems. I would do the exact same thing, keep, change, flip. So I would keep the first, all right, starting with number 7. Change division to multiplication, keep, change, and then I would flip the last fraction, right, and make it x squared plus 2x plus 1 over x squared plus x plus 1. All right, and then factor every part of it, right? X to the third minus 1, that's another difference of cubes. So that's going to be an x minus 1, x squared plus x plus 1. Same opposite, always plus. On the bottom, I have a difference of squares, x squared minus 1, x plus 1, x minus 1. All right, times, it looks like on top, I have a perfect square trinomial. If you didn't recognize that, you would just find what multiplies to 1 and adds to 1, and it's going to be an x plus 1 and an x plus 1. All right, and on the bottom, that can't factor, right? Even though it can't factor, that's fine. You would recognize that this cancels with this on the top. All right, and then looking at everything else that cancels, it's an x plus 1, an x minus 1, and the only thing that we're left with is this x plus 1. All right, so the next few are going to work kind of the same way. All right, so I'm going to keep, change, flip, keep, change, flip. So this is going to be an x over x minus 1, change the division and multiplication, and flip the last fraction. So x squared minus 1 over x squared. All right, and then so we can factor and cancel, right? The only thing that really factors here is this difference of squares. It's going to be an x plus 1, x minus 1. So then you're just looking for what cancels. The x minus 1 cancels. The x's cancel, right? There's 1x on top and 2 on the bottom, right? So again, think of it like x and x times x, right? One of the x's cancels. And then you're only left with an x on the bottom and an x plus 1 on top. So you would leave it alone like this. Again, you cannot cancel those x's, right? Looks tempting, don't do it. It's not correct. All right, so then the last one here is another division one. I would keep, change, flip. So keep the first, keep the x squared minus 14x plus 49 over x squared minus 49. Change the division to multiplication and flip the last fraction. So I get x plus 7 over 3x minus 21. All right, and then factor every part of it, right? Looks like this can be a perfect square trinomial. If you didn't recognize that, again, I say it every time, you would just find factors of 49 that add to negative 14, and it's a negative 7 and a negative 7. All right, and then on the bottom, I have a difference of squares. X squared minus 49 is going to get you an x plus 7, x minus 7. All right, times, I have an x plus 7 on top, and then 3x minus 21, I can take out a GCF of 3. So it's going to get me a 3x minus 7. All right, and then so I can cancel out common factors. It looks like I have an x minus 7 on the top and on the bottom, another x minus 7 on the top and on the bottom, and then I have an x plus 7 that cancels. Almost everything cancels except for this 3. All right, common mistake from here that I see, it's nice that things cancel, but some people will just write 3. Keep in mind the 3 is on the bottom, so it needs to stay on the bottom. The only thing left over on top would be 1. I would write the 1 as a little placeholder. So 1/3 would be the answer here. All right, so hopefully not too bad. Hopefully another kind of light lesson. It goes hand in hand with our simplifying that we did in the previous lesson. All right, so hopefully not too bad. It was just a whole bunch of factoring, canceling, factoring, canceling. All right.